Let's take a look at the beginning of this investigation 1, which is titled Ways of Comparing, and we're looking at ratios and proportions. We've talked about ratios and proportions many times. Remember, ratios and proportions are essentially the same thing, or I guess they're not. Ratios are comparison of values. So for example, a ratio would be 2 to 7, right? And a proportion is when you set two ratios equal to each other. So that would be a proportion, right? And you can use proportions to solve lots of problems. If you can come up with two equivalent ratios, set them equal to each other, you can find missing parts of triangles, which we've done already in the last unit. So we're going to be doing much of the same, but just different contexts throughout. So in 1.1, our big story, our overarching story is going to be on surveying options, analyzing comparison statements. Now remember, everything that we do in mathematics from K through 12 is all about a story, right? From beginning to end. We've already talked about ratios. We've already talked about proportions, and those things we're going to continue to build into that. So if you're looking for a metaphor into like a book, it's like the next chapter or the continuation of that same story. Like this is the 8th book of a 12-part series, and these are the same characters. These characters, the enrichment of the characters, you're getting to know more about them and more about their development and how they interact with each other. We're doing the same thing. We're learning more about ratios, more about proportions, so we can love them and understand them a little bit more and how they interact with the world around us, or the other characters of the book, like all of the integers, all of the decimals, all of the fractions. It just becomes more of a richer story as you go throughout the books, and we're in, let's say, the 7th book right now, since this is 7th grade math. So we're going to be tying all of that into the story of surveying options, right? And we're looking at this ad right here. So which soft drink do you think is better, Bolda Cola or Cola Nola? Now I know the names are kind of silly. If you can't get over that, then let's call this Pepsi and let's call this Coke, okay? So we have Pepsi and Coke that we're comparing, and we're looking at the different stats that come off of asking so many people which ones they prefer. Now with that as our overarching story to help us learn more about ratios and proportions, here is what's happening. It says the marketing club at Nielsen Middle School is studying surveys and other marketing strategies. One of the surveys is about people's preferences for 2 different kinds of cola. Club members have various opinions, right? So remember, Bolda Cola, that was what we're going to call Pepsi. And Cola Nola, we're going to say is Coke. All right? So number 1, these are all statements about the cola taste test results. So you took the survey, and then these are the results. Number 1, in a taste test, people who preferred Pepsi outnumbered those who preferred Coke by a ratio of 17,139 to 11,426. Number 2, in a taste test, 5,713 more people preferred, and this is going to be Pepsi. Now, if you look, this number comes from the difference of 17,000 and 11,426. So that's where that number comes from. In a taste test on number 3, it had 60% of the people preferred Bolda Cola. Again, that's Pepsi. So 60% more people preferred Pepsi. That's what number 3 is saying. Number 4, in a taste test, people who preferred Pepsi outnumbered those who preferred Coke by a ratio of 3 to 2. And so this is a ratio of Pepsi lovers to Coke lovers, right? So those are the statements that can be said about this particular survey. Now, what you're doing is you're answering part A, numbers 1 through 5, using those 4 statements right there. Go ahead, pause the video, and answer 1 through 5 using those statements. And number 1, describe what you think each statement above means. Well, essentially, all of them are meaning the same thing. They're all saying that people preferred Pepsi over Coke, right? And number 1, it's using the total number of Pepsi lovers over the total number of Coke lovers. And number 2, it's just saying this is how many more people preferred Pepsi. 3, it's using percentages, right? So this is the first time it's not using the actual numbers. It's using percentages. And 4 also is using ratios. It's not using the actual number of people surveyed. It's using a ratio to show you that Pepsi is preferred 3-2. On number 2, which of the above statements do you think would be best in an advertisement of Coca-Cola or Pepsi? Now, this is up to you. I think probably a good answer would be number 2, because, hey, wow, 5,713 more people preferred, but you don't know how many people were asked this question. It could have been 17 million. And so a difference of 5,000 is not really that much, right? So you don't know how many, but that's a good one. It could get people who are ignorant of numbers and don't ask those follow-up questions. Be like, yeah, Pepsi, automatically Pepsi, because more people like this, right? But it's up to you. Any of these would be okay. 4 might be a good one too. 3, people can better understand, well, 60%, that's more than 50%. So yay, Pepsi. Number 3, is it possible that all 4 statements are based on the same survey data? Explain your reasoning. So this one is a simple yes, because all of the numbers fit up. Like, for example, this is a difference between those, which makes sense. 60%, if you figure out how many people this represents of the total, it is 60%. And then if you take 17,139 divided by 11,426, you get 1.5, which is equivalent to 3/2. So yes, all of those numbers fit together. They are from the same survey. In 4, it says, in what other ways could you express the claims in the 4 statements? There's infinite number of ways, right? The one that I came up with right off the bat is, listen, this is Pepsi the Coke. So you could also say 3-5 or 3 out of 5. Because there were 5 people in this case, out of every 5 people asked, 3 of them preferred Coke. That's just one example. There's multiple ways you can restate some of these things to say the same thing. Number 5, suppose you surveyed 1,000 cola drinkers. What numbers of Bolda Cola and Cola Nola drinkers would you expect? So on number 5, we would have to set up more of a ratio. So for example, 60%, I guess you wouldn't even have to do a ratio. If you know 60% is a Pepsi and the total of 1,000, 60% of 1,000 would be 600. And then 400 preferred Coke. Okay? So on that one, what numbers of Pepsi and Coke drinkers? 600 for Pepsi, 400 for Coke. On B, you're doing something similar, but kind of in reverse. 1 through 6, those are the statements, and you're trying to determine if those statements are true or not. So let's understand the information that we're given. So students at this middle school are planning a year-end event of the 150 students in the school. So that's what we have to know, 150 total students. 100 would like an athletic event. And it says 50 would like a concert. So you notice that these two, they add up to 150, which is the total. Okay, but 100 of them said athletic, 50 is concert. Everybody had to vote. Now what you're doing is you're going through each one of these statements and determining, is that statement true or is that statement false given this information up here? For example, At Nielsen Middle School, 1/3 of the students prefer a concert to an athletic event. Well, concert to an athletic event. Let's figure out, well, there are 50 that prefer a concert out of 150 total, right? And so that simplifies down to 5/15, which simplifies down to 1/3. So yes, number 1 is true. That one is true given our data. So go ahead and go through, do 2 through 6, and then come back and see how you did. Okay, and number 2, students prefer an athletic event to a concert by ratio of 2 to 1. So athletic event, concert, that simplifies down to 2/1. So yes, that fraction is the same as 2 to 1. So that one is true. Number 3, the ratio of students who prefer a concert to students who prefer an athletic event is 1 to 2. So that's the same question, just flipped around. So yeah, that's going to be 50/100, which is 1 to 2. So that's true. Number 4, the number of students who prefer an athletic event is 50 more than those who prefer a concert. Yes, so that would be 100 minus 50 is 50. So that one is also true. Number 5, the number of students who prefer an athletic event is 2 times the number prefer a concert. So yes, if you take 2 times the number that prefer a concert, that gives you 100, and that is true. So that's true. Number 6, at Nielsen Middle School, 50% of the students prefer a concert to an athletic event. So 100 people preferred a concert. Oh, no, so that's an athletic event. We already did this, but 50 preferred a concert out of 150 total. That is about 33.3%. So this one is false, and we already did that up there. Or something similar, just ask the question a different way. Now let's take a look at part C. So study each correct comparison statement. So up here, from B, what information does each statement give you about the situation? So this is very similar to what we looked at the beginning. What information does it give me? And then what information is left out? So for example, number 1, at Nielsen Middle School, 1/3 of the students prefer a concert. Well, I mean, it just doesn't give you the actual numbers of how many preferred a concert. It just gives you a ratio that's equivalent to the big ratio of 50 out of 100. So it means the same thing, but it looks and feels very different. 1 out of 3 versus 50 out of 100. And that's what they do in 2 and 3 as well, is they use ratios. They leave out the actual data, the actual information. Numbers 4, that includes the actual data, the actual information. So that's different from 1 through 3. And then 5, that's the only other one that's right. It does a little bit of both, but it doesn't give you any information about any numerical information other than the fact that it's 2 times. So it's unique in that way. It doesn't necessarily give you a ratio or percentage. It just tells you that it's 2 times, which is more like a scale factor than anything else. Number 2, use the Nielsen Middle School survey results above. Suppose you consider a sample of students of a larger school. How might you predict the number of students who prefer an athletic event to a concert? Very good question. Now, you want to know, for example, how many would prefer a concert. So, for example, 50/150 preferred the choir, the concert choir. So if you have a school of, let's say, 1,300, you can set up a proportion. Well, proportionally, if the school of 1,300, they're going to have similar likes to the school of 150, then you can use a proportion because it should be very similar. So we set up 2 ratios that should be the same or close to the same, and we solve. and I made this up randomly so these numbers don't work well, but if you take 150 times 8 2/3, that will give you 1,300. So we're going to take 50 times 8 2/3, and that gives us a value. I'm going to erase the x. That gives us a value of 433 and 1/3, but we're not going to include that 1/3 student. So what this means, if you were in charge of preparing your school of 1,300 students for a possible choir performance, and you want to know how many people should I prepare for, your answer is 433 based off of data from this other school of similar-minded students. Okay, so short answer is you set up a proportion to figure out for any number of total students in whatever school. That is all that I have for you in 1.1, surveying options. And again, remember, this is overarching story, these different chapters. The character developments are going to be richer, but they're still there. They're still involved in each other's lives, and everything that we've been talking about is very important as we move forward.